ch1.5, and we are doing arithmetic combinations of functions.
Oh, my favorite.
I'm sure it is. Our essential question is, can you find arithmetic combinations of functions by adding, subtracting, multiplying, and dividing? This sounds a lot harder than it is, so do not freak out. Notice we have all the things you've seen: sum, difference, product, quotient. And all they're telling us is that f plus g of x is equal to the f of x equation plus the g of x equation. Yeah, we're just adding. And here, f minus g of x, we're taking the f of x, and what are we doing? Subtracting, minusing it. And the product, guess what we're going to do there? This is where it kind of gets harder for us. And when I have a quotient, these are those rational expressions that you need to know. But remember, in the denominator, what can we not have? Zero. So we cannot have 0 in the denominator. It's out very nice for us. Example 1 says, given f of x equals x squared. So we have our f of x, and g of x is equal to 1 minus x. Find f minus g. So what is my f equation that I'm going to start out with? X squared, and we're subtracting the whole g. Because remember, this is what we're working with, f of x minus g of x. So what am I subtracting? I'm taking the x squared and I'm subtracting all of the g, which is what? 1 minus x. And to finish us off, what do we have to do with that?
Distribute.
Good. And let's put it would be x squared plus 1 plus x. But if we really wanted to make the math teacher super happy, how would I answer that in descending order? Awesome. X squared plus x plus 1. Good job. So David asked, wouldn't the 1 be negative? Yeah, because we subtracted the 1. Very good, David. So let me use my little eraser right there. Voila. So this one would be negative. Thank you.
So do you factor it?
It's telling us find g times f of x, given that f of x is 1 over x, and g of x is x over x plus 1. So what are we doing here? What are we doing? If it says g right next to f, that means we're doing what operation? Multiplication. Now, it also tells us that x is going to equal what? -3. So there are two things we could do. The first thing we could do is we could take, and I'm going to do it this way, we could take g of x, which is x over x plus 1, and multiply it by 1 over x, and then solve from there and plug in -3. So let's solve from here. What can we simplify here, Hannah? Good, the x's can cancel out. And so my answer is 1 over x plus 1. But now they're telling us that we could go ahead and instead of putting in x, we're going to put in what? -3 plus 1. So what is the answer?
-1 over 2.
Good, 1 over -2 or -1 over 2 or -1/2. All of those answers are the same. Would it be the same if I put the -3 in first? I want you guys to try that on your own and tell me if it would be the same. Example 3. Given f of x equals x squared and g of x equals 1 minus x, find f plus g of x. So now we're just doing what operation? Yep, we're just adding. So I'm going to take f of x first, and I'm adding it to the g of x. And in this case, it doesn't really matter if I have parentheses or not. Obviously, with the difference, it would. So what's the final answer in descending order, Jacob?
X squared plus minus 1x plus 1.
Good. Minus x plus 1. Awesome job. All right, example 4. Given f of x equals x squared and g of x equals 1 minus x, find f divided by g of x, then find the domain. Remember the domain. The denominator cannot equal 0. I'm going to give you guys a chance to do this. All right, so remember that we're going to take the f of x first, so that's x squared, and we're putting it over 1 minus x. And that is what, if I really wanted to line this up properly, I would write it like this. F of g of x is equal to x squared over 1 minus x. But what did I forget to name here? What does it tell us to do? Find the domain. What can the domain not equal? You're right that the denominator cannot equal 0, but in this case, the domain, the x, is every number except what can x not equal? 1. Okay, so if I plugged in 1 right here, 1 minus 1 would make the denominator 0. So the whole answer is this right here, without the arrow. All right, so we're moving on to what we call compositions of functions. We did this last year. I love it. It's super fun. Okay, and what this is telling us to do is when you see f of g of x, that is saying you're putting the g of x equation into the f equation. So if it says g of f of x, what equation will be on the inside this time? Good. The f of x will be on the inside, and the g will be on the outside. So we're going to put this to practice. All right, so example 5. Sorry, I couldn't see that. It says find f of g of x for f of x equals 1 over x, and g of x equals 2x plus 1. Let's do this first, okay? So we are taking the g of x equation. I'm going to highlight it for you. See this equation right here? We're taking this and we're putting it in for that x. Does that make sense? So I'm taking the equation of g of x and I'm just putting it in for the x. So let's do that together. F of g of x. My blueprint will be the f of x, 1 over. But because my g of x is a little bigger, I'm going to put in that whole thing. So this is going to be 2x plus 1 underneath. Does that kind of make sense? They did not tell us to state the domain. I would know that the domain would be all real numbers except x could not be negative 1/2 here. Interesting. Now they tell us, if possible, find f of g of negative 1. Well, I've already solved for f of g of x right here, right? So now all I have to do is put in one number. Now that I have my blueprint, I know that f of g of negative 1, instead of putting in x, what am I going to put in? Good, I'm just going to put in negative 1 instead of putting in the x. I'm going to use that blueprint of f of g. The only time I would switch it is if they switched it. So here's what we have. 1 over 2 times negative 1, which is what, guys? 2 times negative 1 is negative 2 plus 1 is negative 1. So the answer of f of g of negative 1 is negative 1. Not so bad. You could probably do that in your head. All right, and then our last question, we're still sticking with that same blueprint of f of g, but in this case, we're going to put in what for x? We're going to put in negative 1/2. So I'm going to blow it up. We know we're using the same blueprint, and instead of putting in x, I'm going to put in what? Negative 1/2. And what happens with my 2 and 2? And I know that 1 over negative 1 plus 1 is, so what would the answer to f of g of negative 1/2 be? What would it be? Undefined. Remember, you can never have 0 in the denominator. Guys ask me, well, what happens when they switch it all up? So we're going to start this one. We might not have time to finish it, but let's start with A. A is saying find f of g of x. So I'm just going to highlight for you so you can see this immediately. We are taking the g equation. I'm rewriting the f blueprint, but instead of putting in this little x, what am I putting in? All of g, which is 4x squared plus 1.
What does this have to find?
Oh, find the following. Meaning find A, B, and C. So we're taking the f blueprint, and instead of putting in that little x, I'm going to put in 4x squared plus 1. And you get to distribute and add like terms. Distribute for me, Luca. 8x squared plus 2 plus 5. Answer, everyone? That's not so shabby, right? Okay, let's just look before we close up today. Let's go ahead and look at the next one. Now they're telling us to take the whole f of x, right? And we're going to put that in here. So what am I going to have to do if f of x is a binomial and the g of x is telling me to square it? I do have to FOIL. So I'm going to give you a minute to write that one down, and we'll see if we could get through it before y'all leave. Can you guys FOIL 2x plus 5 in your noggin? What is it? 4x squared. 10x and 10x is going to be how many x's? 20x and 25. Ooh, but we have to distribute that all through by 4, right? What's 4 times 4x? X squared. 4 times 20? 4 times 25? And so it looks like our final answer is 16x squared plus 80x plus 101